weight could be one of those as well. And obviously it can be visualized. I will show you in a moment a different graph for different customer, which is taking into account specifically what you meant. So basically weight and for example intensivity of particular relationships. So I will get back to this. So this is one of the views. And on the right hand side you do have top entities. This is just a demonstrator, but I wanted to give you a full walk through this. So once, for example, we see that John Smith, it's very active in this graph. So let's take a look. His activity is also quite high in the recent few days. So let's take a look at his profile. So so his profile, it's, and here we are only querying the data which is relevant to John Smith. So we are not querying anything more than that. We are also querying the events from the system. So we are trying to find out what's the history. So when this particular user was registered, what was the risk level when he was registered, how this risk level has changed, what was the history of his connections with other people. So all of this can be useful for the analyst to take some decisions. Here we have very simple graph of topics which were discussed by John Smith, and we see that Paul Miller, for example, was discussing more or less the same and very dangerous type of activities like our John Smith. Obviously, we can do the same with locations. So to find out that again, Paul Miller is the person who should be maybe monitored more closely in the system. So this is just to show you how those graph visualizations are implemented at the moment. And here we do have several types of research activities. Obviously, this is a view on HDFS. So we do have a HDFS cluster with the raw messages and the text-enriched messages in there. This is not extremely exciting to go through those, to go through this data set. But what is a little bit more interesting, I think, is the projection we are doing. So we are putting all the data and all the results of the analysis on the timeline. So we are trying to help the analyst to, for example, say that specific time mentions, specific topics, specific entities, specific locations were mentioned on the very particular day. So it may be of use for someone to take those decisions a little bit more quickly. So for example, around 2 o'clock, let's say, some maybe bombing Steve Johnson and Paul Miller. I hope none of you it's Steve Johnson or Paul Miller, especially Paul Miller, because he is here for the third time. And particularly high activity was what was discussed in the social media was High Court of Australia and Canberra. Again, this is here an oversimplification, but proving the point that when we get this data in this kind of way, they are way more meaningful for us. And locations, so something what can be interesting for you, although this implementation is very, very simple. We are simply using our internal e-location server, and we are putting the tweets and the messages as they arrive to the system on top of the map. So we are able to, for example, tell where the certain communication was originated. So I think that can be also expanded to other 5 minutes. Okie doke. So to other stuff as well. So we do have alerts and all, and so for example, if you are interested in raising the alert in the right moment, for example, because all of this you see now, it's something post-active. So if you would like to be notified before this would happen, then obviously you can subscribe to different types of for example, events like new connections, risk level changes, new metadata, communication rate changes. So for example, if John Smith was again very quiet and now with tweets like crazy, this is probably something what should be interesting for us. Okie doke. So that's the social intelligence as it was created, I think, 6 months from now. But since then we were not really sitting doing nothing. We also tested a few other ways of how we can visualize the graph data. So here you have a view on big data discovery, and I've created a very simple project for you, which is based on data sets that I've created in the recent few days. I'm not really sure if you're familiar with data discovery, but this is not that much relevant now. It's what is important for you. That's these kind of graphs, so location and graph data can be embedded in the discovery tools which are used by the analysts. And obviously here it's a network of smugglers with their metadata like phones, like bank accounts and this sort of stuff. For example, same network after the CDR process, after billing processing stage. So we take the billing of the people. This is not something I've created. I've used the data sets that we have we received some time ago, and based on the data, I was able to calculate the thickness of the lines of the links expresses the intensity of relationship, for example. So you have potentially very different people connected with each other. So you can do a number of different analytics. And for example, this is something I have implemented in the last 2 days. This is another data set, and this is implemented on top of Cytoscape. So this is based on Cytoscape, and here you have a fully blown set of algorithms which were discussed by guys yesterday. So all the algorithms you can run on top of property graphs. I don't think all of them can be executed on this data set, but some of those definitely can. Like between the centrality, for example, here we calculate which of the nodes it's between the other nodes. So basically, which one is, for example, the most important for us to connect different communities. So if you are targeting some marketing campaign, this could be the person you should address to have maximum coverage of the neighborhood, of the rest of the network. You can, for example, degree centrality is obviously something we can do. So it's trying to compress on the size on the screen we have here, but once it stabilizes, we can of course play with this graph, and so we can also add more nodes, add links, and add other stuff. And here, for example, we do have this degree centrality. So based on number of connections, we are highlighting in a sort of way the most central people in the graph. Again, might be of our interest, depending on the use case, depending on the customer, depending on the requirements. This might be used in different ways for dealing with different use cases. Okay, so that would be it, I think. So maybe you have some questions. Okay.
How long have you had this in place, or at least how long is it taking you to develop this to this point?
It was really crazy period and very intensive one when we implemented this. So I think it took us a few weeks to put this thing together. And the problem is that most of the stuff it's hidden behind the scenes. So basically, all this NLP processing was really complex stuff, and this costs this was investment to make and to embed this into the solution. But I think the graph part was really easy. I think it took us, I don't know, a week or two. So that's more or less the complexity. Again, this is demonstrator, but it's, I think, capable to do different stuff as well. And the full project, it's at the moment faced, I think, around 3 stages. And I think that's the plan for now.
What size is your team?
Around 20 people, but not all of them were involved, obviously. Actually, not many survived this pace of work. No, just joking, but I think it was a team of 2-3 people who did this. So.
How does a natural language processing happen? Does that happen within local technology, or is it else?
How does the language processing happen? Natural language processing happens. So that's a very good question, because it's really complex, and here we had to involve partners, because this stuff is really complex, it's very much related to the language, to the linguistic, to all the syntax and all the complexities of the languages as we have now. And we have fusion languages and non-fusion languages. English is non-fusional languages, which is a bit easier, but fusional languages like Polish are completely different beasts. So this is really hardcore stuff.